Welcome back, chemistry fans. So what we've got to now is your homework for Unit 12, Topic 3. Let's get into it. We've got a couple of formulas we need to work with. So let's start them out here. We got to share our screen here. Number 1 is asking us to figure out what is the heat of formation if you have 45 grams. Now, normally you would have 242 kilojoules if you have 1 mole, but you don't have 1 mole. You have something different from that. So we got to figure out how many moles we have to figure out how many kilojoules we have. So we got 45 grams that we would need to divide by the weight of water off the periodic table. So this is just your mole map going from grams back into moles. That's a division process. So 45 divided by 18, the weight of water off the periodic table is 2.5 moles. We're going to multiply that times 242 negative, and you end up with 605 as your answer. 605 negative kilojoules, meaning it's exothermic, meaning it's giving off heat. Okay, now I've got this balanced reaction. It may not look balanced, but it is balanced right there. I'm going to use blue so we can start seeing the difference in colors. And we are going to have to figure out the heat of reaction for this. You are given the heat of formation for each one of these. Then what you have to do is products minus reactants. So we start with the 3 times the heat of formation for water, which we just used, 242. So that's my products right there. Now we're going to subtract from that the heat of formation for the reactants. Well, it's 0 for the hydrogen, minus 1 times 143 for the oxygen. Now, I don't need to put the 1 in there, but that's an unwritten coefficient 1 that's right there. So I've got 3 times 242, and that is negative. So that's a negative 726. And then minus 143, well, that means the negatives are just going to be added together. So 143, and you get 869 negative kilojoules. So that's my second answer that I've gotten. All right, now number 3 is asking us to do a Hess's law problem. Now these are difficult. These are right up there with the balancing of the redox problems. What we have to do is add these 3 values together to get the total heat, because they did this in steps. So I've got 3 different steps that get us to the total. Well, what we're going to have to do is figure out how do we get to that point. So we circle, and that means we cancel. If we have to reverse the reactions, we will need to reverse the heat. If it's negative, it will become positive. So let's start with 4 NH3s. In which reaction do you see those? I see those in B, but I see them on the wrong side with the wrong amount. So I'm going to multiply everything by 2. Now it's with the correct amounts, so I got to multiply my heat by 2, but I've also got to reverse this. So B is now going to be 4 NH3s producing 2 N2s plus 6 H2s. And that heat that goes with it, the heat of reaction for that part, is going to be positive 91.8 times 2. All right, so we've gotten our B taken care of, because I found one thing that's correct on B. I know I don't have to deal with B anymore. So let's go find something else. Well, oxygen's in 2 places, so I'm going to skip that. Let's find NO. I see NO is right there, but it's with the wrong amount. So I need to multiply everything by 2, and that means I need to multiply the heat by 2. So now I know that I've got A and B correct. Now we're just looking for part C. Well, what's it? Oh, wait, it's also with the wrong amount. I see that it's on the correct side, but it doesn't have 6. So that means I need to multiply everything by 3. Oops, that would be 6 there, sorry. And this would be 6 also, but I need to multiply this value by 3. So now I've got all of my work done. I've just got to add it together. So I've got 180.5, which is negative, times 2. So that's going to be negative 361. I've got negative 483.6 times 3. That's negative 1450.8. And then I have a positive 91.8 times 2. That's a positive 183.6. So now I'm just going to add these three values together to get my final answer. So 183.6 minus 1450.8 minus 361. And what I end up with is a negative 1628.2 kilojoules. That is my final answer. It's hard to read my work there. That's my final answer. That means it's exothermic also. So all three of my answers ended up being exothermic, giving off heat. In this case, it was calculated in 3 different ways. Thank you very much for your time. I will talk with you again soon. Bye-bye.